But there is another way that we can name this angle by coordinates that are equivalent to cos of pi minus a and sine of pi minus a if we relate it back to this angle here. So what would you say about the y coordinate? How do they relate, this point and this point? Well, the y coordinate is the same. So the sine of pi minus a is actually the same as the sine of a. What would you say about the x coordinate? Well, it's simply the opposite. It's just on the other side of 0. So it is negative the cosine of a. Right? Right? And so you have another name for this coordinate. So basically what we've said is we can take any situation where we have an angle of pi minus a, so we can reference an angle by counting back from 180 degrees or pi radians, and then we can simplify it by saying, okay, well that's the same as the cosine of whatever angle we happen to be working with. Same with the sine. If you have this angle that goes back from 180, you can write any angle in quadrant 2 as this, pi minus something, okay? And if you can do that, then you can also simplify it to being the same as the sine of a, which is really helpful, okay? Related angles. These two angles are related, that's how. And you have basically what we're saying is that pi minus a relates to a this way, and pi minus a in the sine world relates to a, it's the same. Okay, good, carry on. Next box, you have pi plus a, which is this arrow, all the way around from your initial arm along the x-axis. This is pi plus a. So what are the coordinates of the point that we make down here? Well, it's the cosine of pi plus a, comma, sine of pi plus a. I'm doing one thing not 100% clear. We need to make sure that this is actually in brackets. The angle, it's not the cosine of pi and then subtract a. The angle is pi minus a. So we need to make sure that's in brackets. So we're going to do that all the way down. Good. And now you can think about it. Well, how does that relate? Well, in quadrant 3, both cosine and sine are negative. The value stays the same. If you kind of draw that little box, then you can see that the value is the same, but the sign changes. So cosine of pi plus a is actually the same as the negative of cosine a. And same with sine. Sine pi plus a is the same as minus the sine of a. And then our last box there. We're going from our initial arm all the way around the circle, almost all the way around the circle, to 2 pi minus a. So what do we have? We have the cosine of 2 pi minus a, where your angle measurement is in brackets, comma, the y-coordinate is the sine 2 pi minus a. And we can reduce this one more step because 2 pi and 0 are the same. When you go around a circle, it doesn't matter how many times you go around it, you can go around, 720 degrees, you're still going to be back here at 0, okay? So 2 pi can be subbed out for 0, which means that in your next line you can write the cosine of simply negative a, and you have the sine, and here's your y-coordinate, of negative a. And now these we can simplify again with respect to this reference angle in quadrant 1. You can see that the cosine is equivalent, the value. So the cos of negative a is actually the same as the cos of positive a. And the sine of negative a is actually the same as negative the sine of a. This relationship ends up being a really important property that we work with once we get into talking about waves. So you can trigonometric function it actually ends up being a wave, and there's a relationship here between the cos of negative a is equal to the cos of a, and the sine of negative a is equal to negative the sine of a. Okay, so really helpful notes there. And then from that, we, so your bottom line there, if you know the value of cos and sine, what else do you know?
Tan.
Yeah, if you know the value of cosine of a and sine of a, then you also know the value of tan of a, because it is simply sine over cosine. So we're going to develop all of the corresponding sine, cosine, tangent of all of these angles that we just did. We're going to put it into a nice list on the bottom of that page still. Hopefully we can fit it in. So basically you're going to have 4 little lists. I guess 3 little lists, because the first one is just the sine of a, the cosine of a, and the tangent of a. But here we go. We got, so you're looking at having 3 columns by the time we're done here, so page out your bottom of page 13 accordingly. We're looking at the angle of pi minus a. So the cosine of pi minus a we determined is equal to negative the cosine of a. The sine of pi minus a we determined is equal to the sine of a. The tangent of pi minus a then is equal to the sine of a over negative the cosine of a. Okay, so that looks like this: sine over negative the cosine of a, which we can reduce. We could put that negative sign out front. This is just negative the tangent of a. Did you follow that? Okay. I kind of left out a step. I left out this step. You don't have to write it, but I'm just showing it to you. I left out the step that says the tan of pi minus a is the sine of pi minus a over the cosine of pi minus a. And from there, you can use these 2 things that we already wrote down to simplify, and from there you can go back to negative tan of a. Okay? It's the only way to know that the tan of pi minus a is equal to negative the tan of a is to find out this relationship here, these 2 relationships, sub them into, you know that tan is sine over, right here, sorry, sine over cos of the same angle. And because we can simplify these 2 expressions, then we can reduce it down to there. Okay? If you need to write that, go ahead. And we're going to move on. Pi plus a. The cos of pi plus a, we already determined, is equal to the negative of the cos of a. The sine of pi plus a, we determined, is equal to negative the sine of a. Here we are in quadrant 3, right? So quadrant 3. Anyway, carrying on. Tan, again, I could write this step. The tan of pi plus a is equal to the sine of pi plus a over the cosine of pi plus a. But we already know that the sine of pi plus a is negative the sine of a, and the cosine of pi plus a is negative the cosine of a. Negative over a negative is a positive, so this is just tan of a. And your third set is cos of 2 pi minus a. We determined that was equal to the cosine of a, because it's equal to the cosine of 0 minus a, which is just the cosine of minus a, and the cosine of minus a is equal to the cosine of a. Okay? Then we have the sine of 2 pi minus a, which again is just the same as the sine of negative a, which is the same as negative the sine of a. You can refer back to those diagrams if you're not sure how we did that. And then the tan of 2 pi minus a is equal to the sine of 2 pi minus a over the cosine of 2 pi minus a. The sine of 2 pi minus a in the numerator is actually the same as negative sine of a. Cosine of 2 pi minus a is the same as the cosine of a, all positive. So we end up there with the negative tan of a. So now you have a whole list of things that whenever you see them, you can relate them back to that easy angle in the first quadrant. Okay? You can relate it back to just angle A, just angle A, just angle A, just angle A, angle A. Okay? That's why they're related angles. And that's going to work for any angle in the whole circle. You'll be able to take any angle with any radian measurement and relate it back to, we related sum to 0, we related sum to pi minus something or pi plus something, and then you have angles that are 2 pi minus something, okay? So you can see how all the quadrants are taken care of. Any angle in the whole unit circle can be reduced in this way, and you can get the 3 primary trigonometric ratios in this way. From there, you can get the secondary trigonometric ratios. All right, example 1, we are asked to simplify the expression cosine of x plus the cosine of pi minus x minus the cosine of pi plus x minus the cosine of negative x. And really all we're doing is relating back to those related angles, relating back to our angle x. So if we have our rule list in front of us, or we can flip back and forth, cos x, that's as reduced as it's going to get. That's just the cosine of x. The cosine of pi minus x. So I look at my chart, I find pi minus a, or pi minus x, just means pi minus any angle, and the cosine of it is equal to minus the cosine of a, which in this case is x. Okay, so how I've recorded it is I took down that addition symbol, and then I changed this term to negative cosine of x. If I were doing it, quickly, then I could right away just go minus cos x. Okay. Anyway, carrying on. The next one.
You just get 0.
Yep. We're looking for cosine of pi plus x. So in the world of pi plus a,
It's just cos x.
it's negative the cosine of. So we've got negative the cosine of x.
I just put plus cos x.
Yep, that's fine. If you want to simplify it that way right away, you can skip from step 1 to step 3 here. It's not a problem. And the cosine of negative x, that's our last section. Cosine of negative a is the same as cosine of positive a. So here we've got cosine x. Simplify one step further. I've already done this guy. Negative cosine x minus negative is plus cosine x. And then minus cosine x. What do we end up with? We end up with 2 positives cosine x and 2 negatives cosine x. Well, this thing reduces to 0. Okay? Let's look at example 2. We're going to simplify, and there's a little hint there to help us. We're going to draw a representation of this angle. And if we ever see a secondary trig ratio, we're going to relate it back to its primary trig ratio, then solve it, and then flip it back into a secondary. But we'll get to that in a second. First, A just has the sine of x minus pi. Why is this one a little trickier?
It's it gets you like hypothetically there's like a line that's undefined, so it goes straight up. And then just subtract x and goes to the side of it.
Not 100% sure what you're saying, but so in the statements that we have, the angles are written in terms of pi minus a, or 2 pi minus a, or pi plus a. This time x is first. So what we're going to do is draw a little circle. See if we can figure out where this angle would be. In order to do that, you can draw.
You know how you also draw a vertical line?
Yep.
And then right, so in the
Okay, so first we're just going to draw this angle, okay?
So let's try
We're going to
this.
start by drawing the angle x, which can be any arbitrary angle inside quadrant 1, basically, okay? So we're going to call this angle x. And then what do we have to do? We have to go backwards pi. Well, pi is the same as 180. So basically what happens is if I continue this guy,
Oh, yeah.
I've gone
I did have pi.
minus pi, okay? And what we're really looking for is now indicated. It goes from our initial arm all the way around to our pink terminal arm. That is the angle x minus pi, okay? That is the angle x minus pi. But now look at what happened. We moved it 100, so we moved it x up, and then we moved it back 180 degrees. So what basically happened is that we created the little angle x right here as well. Okay? We created a little angle x there as well. How do I know that? Well, if you have 180, well, I'm not going to explain how I know it. If we took the positive x, we went backwards 180, which is going to create opposite angles right here with the x-axis, and that's how you know it. So that means there's another way actually to express this angle, x minus pi. It's actually the same as pi plus x. Can you see that? It's actually the same angle as pi plus x. Now we can relate it back to our initial arm, our initial angle, and the way to do that, you can go back to the things that we've already written in our notes. If you don't have the notes and you're getting really good at referencing things, then you know that sine is talking about the y value, and you know that this y value is simply the opposite of the initial reference y value, okay? So, which is the y value at sine of x. Is the value of sine of x. We're going to have the opposite of that. We're going to have negative sine of x. Negative sine x. So again, you have that written in your notes. If you memorize it, that's great. If you can't memorize it, then draw the picture. You're down here. You know your reference angle is x, and you're the opposite. You're in negative land, whereas the sine of x is in positive land. So you just have negative the sine of x. Okay?
And then cos is negative cos x, and then tan is just tan x,
Yes.
based off of what we did on the other page.
Yep. And based on,
And that too. Yeah.
no, that's wrong. Tan. Tan is positive. Cast.
Yeah.
Good. B. B uses a secondary trig ratio, so there's a couple more steps here. We have the secant of x plus pi. The first thing that you're going to do whenever you encounter a secondary trig ratio in any of these types of math problems or solving, you're going to flip it to its reciprocal and express it as 1 over, what's the reciprocal of secant?
Oh, it's cos?
It's cos. Okay, so we have the cos of x plus pi. Now we're going to do all our work dealing with cos because it's a primary trig ratio. We know how it works a little bit better, and then we can flip it back. So what are we going to do? We're going to draw a circle to find out where this angle is. Because once again, it's not given in a form that we're used to. It's x plus pi. It's easier because math is, addition is commutative. So x plus pi is the same as pi plus x. But just so that you can see that that's true, if we take any reference angle, x, and then we add another pi to x, okay? Then we're over here in, what did we add? We added pi. It's really just pi plus x. Pi plus x, okay? So we can rewrite this denominator as 1 over the cosine of pi plus x. We can double check our chart, or we can just look at this point and say, okay, we're in negative land. So this is the same as the negative the cosine of x, Okay, negative the cosine of x equals 1 over negative cosine of x. And now we can flip it back into our secondary trig ratio,
So negative secant of
which is
x.
just the negative the secant of x. Your homework is printed on the next page. It's basically just getting used to applying these related angle formulas. I would recommend doing them all and getting really good at it, because tomorrow you get a whole new set of things that are related within these circles. Okay? So get used to it and get used to working with it. Get used to talking in terms of pi and radians when you have angle measurements. And get used to drawing these circles and relating the angles and figuring out what kind of angle we're actually talking about it, and can I express that angle in terms of pi plus a or pi minus a or 2 pi minus a or just a. And if you can do that, you've accounted for all 4 of the quadrants.